Number 19, integration by parts. We'll notice the logarithmic expression is going to be what we would prefer to call u. So this little statement right here, we'll let that equal u. Now the stuff left over, the t dt, is the dv that we're going to address. I'm just going to make a little note here. This is going to look a little bit weird here. This right here is dv. So I don't know if I like the way that that looks. Maybe I want to take the time to rewrite it. We could certainly do that. Natural log of the t plus 1 times t dt, and then it fits together a little nicer. Here is u, and then here is dv. So if you find it helpful to rewrite it, you certainly can do that. And then what we'll do is we'll give ourselves a little description on what we have. Differentiation tells us the derivative of u with respect to t is 1 over t plus 1. So the differential du is 1 over the quantity t plus 1 dt. Looks like this. dv is t dt, so we integrate to undo the differential, and we get v then is equal to t was to the 1, now it's to the 2t squared over 2, like this, or 1/2 t squared if you'd prefer. uv, got my t squared over 2 times the natural log of the quantity t plus 1. Let's make sure that's in parentheses. Looks pretty good. Liking that. Now, minus, gotta look this direction here. I'll just multiply these two together. I've got t squared, and in the denominator 2, and then a t plus 1, like this. And of course I have my differential dt. Looks good. Green pen, I've got part of my answer right here. Looking nice. But what I need to do now is find out what this is equal to, this indefinite integral. I'm going to rewrite this indefinite integral, made a little room down here. I'm going to take the 1/2 and put it out front. There's a negative sign, so I'm just going to write negative 1/2. And my integral symbol, t squared in the numerator, and then I have a t plus 1 in the denominator, like so. Now what I'm going to do this time, I think I'll just have a little bit of fun with this one. I want to show you a technique that works out really well here. I see a t squared in the numerator and a t plus 1 in the denominator. Now, if I had a perfect square in the numerator that had the factor t plus 1 in it, I could, or wouldn't even have to be a perfect square, but if I had an expression that had a t plus 1 as a factor of it in the numerator, I could cancel those out. And so in life, when you want something, you can just make it happen. So here's a fun technique that we can use. Now I want you to take a look at what I'm doing. I'm going to say minus 1 plus 1. And I'm sure I've convinced you. I haven't changed anything. But what I do notice, I have a t squared minus 1. T squared minus 1 can be factored to the quantity t plus 1, aha, times the quantity t minus 1. So I'm going to do that very thing. It's a fun little technique, and we have lots of fun little tricks that we can use. I'll just write it out very clearly. And what I'm going to do is I'm going to write it as two separate fractions. So I really shouldn't have drawn my vinculum this far, because I'm going to put a t plus 1 right over here, and then I have two fractions. I got a fraction here and a fraction here, and they're added together like this. And what I'll do with this one is I'll rewrite it just a little bit nicer as two indefinite integrals. So I have the negative 1/2, and I'm going to write the t squared minus 1 over the t plus 1 dt. And then I'm going to write this other fraction, minus 1/2 in front of it, of course, 1 over t plus 1 dt. This makes it pretty easy to work with. The first one particularly so, because I can factor that numerator. Those cancel out. This becomes very easy for us to integrate. This one actually isn't too bad either. I think we have it. What we just found was the answer we were looking for. So that's kind of a neat little helpful trick that we can use when you end up with an expression like this to simplify it. Alright, well, let's bring it all together. I should have put a box in red. I wanted to do that in green. Let me put it in green here because I have this part here, and then I've got this part here, and I'll put it all together. Oh, look at that. I've got room right up on the top here. I'll do that. Now you're going to find a variety of ways to represent your answer. I did distribute the negative 1/2 in here to get the t squared over 4 with that negative sign. So I could say negative 1/4 t squared. I ended up writing it t squared over 4 like this. This, of course, comes from the first part, the t squared over 2 natural log of the quantity t plus 1, got that piece, and then distributing through here all the way till I get to my plus c. Don't forget the plus c, that's important.